Okay, so we'll be discussing the graph of the inverse function in this video. Right, we have to know that for the graph of inverse function, f inverse x, and also the original function, right, we can actually sketch it according to their range. And there's one information that we need to know about the graph of the inverse function and the original function is both of them actually reflecting each other. Okay, reflecting each other at the line y equals to x. Alright, so that means when you sketch any diagram for f inverse and also the f on the same axis, basically you will see that the line y equals to x will be the mirror between these two functions. So if let's say I'm having the line y equals to x, right? Okay, so which means that if let's say your graph, your original function is a straight line, so your inverse function will be reflected like this in this way. Okay, if this is the inverse function, then this is actually my original function. So they are reflecting each other at the line y equals to x, where the line y equals to x will be actually the mirror of the inverse and also the original function. Okay, so this is what we need to know when you want to sketch the graph of the inverse function. Okay, so let's have a look for some example that related to the graph of inverse function. Okay, let's say we are having the function f, which is 3x minus 2. For x can be any, is an element of the real number, right? So for 3x minus 2 is the original function. They want to sketch a diagram in a single diagram. That means in the diagram with the same axis. I want to sketch the graph y equals to fx and also y equals to f inverse, making clear the relationship between the two graphs. All right, so if I want to sketch the diagram, sketch the function, so let's say I'm having fx equals to 3x minus 2. When I want to sketch this particular linear function, right, I know that it is linear function, therefore I will need 2 points to sketch the linear function. So maybe I will let x equals to 0, then I will get the value of y is equals to negative 2. And if I let y equals to 0, then I will have the x value, which is 2 over 3. Okay, so from here, I know that if I try to connect these 2 points together, then I will be able to sketch the graph for fx. Right, so I will try to sketch it. Right, so before I start sketching it, right, there's one extra information also that we need to know. When you want to sketch the diagram for fx and also the f inverse x on the same axis, then please make sure that the ratio that you are using for both axes are the same. All right, the scale or the ratio of the both axes should be the same. If not, then later when you sketch the graph, right, the graph, it doesn't look so nice. It doesn't look really, really symmetry at the line y equals to x. Okay, so if you want it to be looks very clearly that it is reflecting on the line y equals to x, then again, please make sure you are setting the ratio or the scale of the x and y axis in the same unit. Okay, so as an example, if I want to sketch the diagram here, basically I will try to label it. Maybe this is 1, this is 2, then this is negative 1, and this is negative 2. For the y-axis, also the same. I try to make it as 1, and this is 2. Then I'm having negative 1 and also negative 2. Okay, so if I want to sketch the original diagram, which is our original function, which is 3x minus 2, at x equals to 0, y equals to negative 2. That means this is what I have here. X equals to 0 and y equals to negative 2. And the next point is at x equals to 2 over 3, the y equals to 0. So 2 over 3 might be here. Okay, so I assume that 2 over 3 is here. So y equals to 0 is this point. So that means I want to connect these 2 points together to obtain the linear function. So I'm having something like this. Okay, and this is my fx. So please make sure that you draw it in a straight line, right? So for me, I'm not able to draw it very nicely. Okay, so if one, then you can try to draw it as nice as possible. So this is my fx. Okay, when I want to sketch the f inverse, then there's a shortcut here that you can try to use it is for any particular coordinate, as example, this one, I'm having 2 over 3 and also 0, right? When I want to sketch the inverse function, right, you just need to swap the coordinate where we are having 0 and 2 over 3. So one of the point for the inverse function will be actually 0 and 2 over 3. So x equals to 0, y equals to 2 over 3, it will be somewhere here. Okay, and after that, the other point that we get is this one, where originally I'm having 0 and -2. So to sketch for the inverse function, I just need to swap the coordinate where I will have -2 and 0 now. So -2 and 0 is this one. Okay, so this will be one of the point for the inverse function. Okay, so this is actually a shortcut for us, okay, to sketch the inverse function. If let's say you don't want to sketch it using the equation, all right. So by plotting, by swapping the coordinate of x and y, then you'll get the coordinate for the inverse function as well. Then you can try to sketch it out. All right. So maybe some students will ask, why we swap the coordinate for x and y will be the coordinate for the inverse function already? It is because of, I think we learned it earlier, right? So function basically means that when you are having x, send x to y using the function, then inverse function will be actually sending y back to the x. So that means you see that it is a reverse function, reverse process. All right, therefore the x and y coordinate, when we swap it, basically we are getting the point for the inverse function. Okay, then after that, if I want to join these 2 points together, then basically it will look something like this. Okay, and this is actually my f inverse. Okay, so the red color one will be my original function fx, and then the green color one will be my inverse function f inverse x. All right, and then one more thing to take note is when we are having the intersection point between the f and f inverse, right? Definitely it will be the intersection of the line y equals to x as well. So if I want to show the relationship clearly, basically I'm having this particular line, the dotted line here that I show you, and this is actually y equals to x. And you will see that the f inverse, the function f inverse, the function f, and also the line y equals to x, they will be having the intersection point at the same point. Always, all right? So this is the small details that you need to know as well. It is because of when we are trying to find out the composite function for f and f inverse, right? It is always equals to x. That means the intersection point is at the line y equals to x. So you can see that this is the intersection point. Okay, for these three function here, fx, f inverse x, and also the line y equals to x. Okay, right. So this is how we sketch a simple diagram for the function, which is a linear function. Okay, so in exam, if let's say they want us to making clear the relationship between the two graphs, right? Please make sure that you show clearly the line y equals to x. It will be actually the mirror or the reflection line, okay, for these two functions, f and f inverse. And at the same time, also you have to show that they are having the intersection at the same point, right? Always at the same point here. Okay, so let's have a look for a harder question, which is example 31. How about if they try to involve, okay, the graph with a quadratic expression? So let's look for this example. I'm having x squared minus 4, okay, where x smaller equals to 0. So first, they want us to get the inverse function of f. So just to recall back, to find the inverse function of f, I will let y equals to x squared minus 4. To find the inverse function, I will make it become x equals to something something y, right? So I have y plus 4 equals to x squared. So my x basically it can be equals to square root plus minus square root y plus 4. Okay, so to find the inverse function, I need to decide because this one basically refer to two answers. One answer is plus square root something, another one is minus square root something. So this is actually the range of the inverse function. So to get the correct range of inverse function, I have to look for the domain of the function. Domain of the function here is actually x smaller equals to 0. That means when I have negative in front of the square root, then only I'll get something smaller than 0. Positive square root something is always greater than 0, right? Which is not tally with our domain here. All right. So this is our final answer. Therefore, to write out the inverse function again, it will be actually equals to negative square root x plus 4. So this is how we find out the inverse function of f. Okay, so for the next question, they want us to sketch the graph of f and also f inverse on the same plane. Okay, so maybe for me, I'll sketch it here. All right, so if let's say I want to sketch a diagram, right? For me, I will always look at the easier graph to sketch first. So to me, x squared minus 4 is an easier graph for me to sketch. Okay, because I know that when I'm having x squared, it should be a U shape. So this is x squared. When I have x squared minus 4, I'm trying to move the graph 4 units downwards, right? So if I move the graph 4 units downwards, it will look something like this. This is negative 4, this is negative 2, and this is 2. All right, and of course, I also need to consider what is the domain that they want us to sketch. So for the domain here, again, you can see that it is x smaller equals to 0, which means that for this x squared minus 4, I only want to consider this part of the graph in my solution, the highlighted part. Okay, so once I know already, then I can draw it in a bigger graph. So I know that this is actually 0 and negative 4, and this is negative 2, 0. Okay, so I'll start sketching it. So again, before I can sketch the function and also the inverse function in the same diagram, I need to always make sure that my ratio or scale for the x and y axis are the same. Okay, so maybe you can try to use a ruler to label it or whatever to measure lah, right? So for me, I'm not very accurately drawing it, but I just try my best, okay, to show that they are actually in the same ratio. Okay, so my original graph, I'm having 0, negative 4. Let's say this is negative 4. Pass through the negative 2, 0. So this is negative 2 and 0. Okay, so it should be a U shape, right? So when I sketch it, it should look something like this. So this is my original function fx. Okay, then if I want to sketch the f inverse, some students, they will try to figure out how to sketch negative square root x plus 4. Okay, then again, for me, because I feel that it depends on individual, but for me, I feel that I want to use a shortcut where swapping the coordinate is quite convenient. So I will want to swap the coordinate only. So for this one, I'm having 0 and negative 4, right? Originally, when I want to sketch the diagram for f inverse, I swap the coordinate with x and y. So now I'm having negative 4 as the x, then 0 as the y. Negative 4x, and then y is here, this point. This is negative 4, 0, right? And then for this point itself, originally it is negative 2 and 0. So when I swap it, it will become 0 and negative 2. So this is actually the 0 and negative 2. Okay, so I already plot out the 2 points here, and I want to try to draw my graph. Okay, maybe to some of the students, they might not able to see clearly how can they connect these 2 points together. How is the curve look like? Is it look like this? Is it look like this? There are many ways for us to sketch the diagram, right? So if you want it to be more confirmed, what you can do is you try to sketch the value, the line at y equals to x first. So let's say this is my line y equals to x, will pass through 1, 1 and 0, 0. Okay, so let's say this is my line y equals to x, and I try to show clearly the intersection point between the line y equals to x and this original graph here. So that means so can you see the intersection point here, this one, y equals to x and also the original function fx. So to combine or to connect my f inverse graph, because to connect the green color points into the f inverse graph, right? I need to make sure that the green color point need to pass through this intersection point, then connect with this one. Okay, so from here you will roughly know the idea, okay? Roughly know the shape for this curve, where it will be looking something like this. All right, so this is my f inverse x. Okay, if you try to observe it, right, when you try to fold your graph okay, along the line y equals to x, you will see that they are reflected each other, okay, on the line y equals to x, where the line y equals to x is like a mirror. Okay, so this is how we actually try to sketch a diagram for the graph for F inverse. Okay, so for me, I didn't use the function here to draw it out, but I just try to swap, okay, the important points, okay, from the original function to get the inverse function coordinate. All right, and also by using the concept that all of them are having the intersection point at one point, so I know that my graph should look something like this for the green color part. Okay, all right, then how about for the last part here? They want us to state the domain and range of F inverse. Okay, again, since we know that the domain of F inverse will be equals to the range of F, right? Okay, so the domain of F inverse equals to the range of F. Basically, what we can do is like, we look at the red color graph. So for the red color graph, the lowest point for the graph is -4, and the graph will keeps on going up. Therefore, the range will be y greater equals to -4. But now we are talking about the domain, right? So the inverse function, domain of inverse function is the same as the range of the function. Therefore, I write it as x greater equals to -4. Okay? Because domain, we are talking about the value of x, right? So I should write as an x. Okay, then how about the range of the inverse function? Okay, the range of the inverse function, according to what we learned earlier, it is equals to the domain of the function. And what is our domain of the function here? Domain of the function is given. It's given as x smaller equals to 0. Therefore, our range also is this one. But I need to change it become y lah. So y smaller equals to 0. So this is how we determine the domain and range for the inverse function. But of course, you can double check your graph and see whether your domain and range for the inverse function and original function are correct or not. So for the green color graph, you can see our green color graph is below the x-axis, right? Which means that it is negative. Therefore, the range of the inverse function is smaller than 0, which is correct. All right, so you can have a look something like that. Okay, you can double check it with your graph to make sure that your graph is correct, is drawn correctly. Okay, all right. So for maybe the quadratic expression part, it will be slightly challenging when you want to sketch the diagram. Okay, but you just need to make sure that a few important points when you want to draw the diagram, that it should be not a big problem. Okay, then let us have a look for the last example for this topic. Okay, let's have a look for example 32. So first of all, they are saying that I have the function g, and then x can be any real number. They are asking why the g has no inverse. So when you look at the g, right, you know that the minimum point is -1 and -2. So your g will look something like this. I didn't draw it very clearly, okay? And then they said x can be any real number. So we are considering the whole U shape. To make sure that it has a one-to-one, it has an inverse function, you have to make sure it is a one-to-one function. But very obvious, this U shape have two intersection points with any horizontal line. Therefore, it is not a one-to-one function, and therefore there's no inverse. So the reason for G not having inverse is you can write G is not a one-to-one function. Okay, then how about for part number B? They are saying that if the domain of G is x greater equals to -1, find the G inverse and sketch the graph of these two. State the domain and range of G inverse as well. Okay, then let's have a look. To find the G inverse, again, I will let y equals to function G. Then I try to move everything to the other side. Okay, when I want to make the square disappear, I take square root at the left. So when I want to take square root, I will need to include the plus and minus sign. Therefore, my x is having -1 plus minus square root y plus 2. Okay, so again, I want to decide which is my correct inverse function. I'm having -1 plus something and also -1 minus something. To decide the correct range, I need to look for the domain of the function g. So domain of function g, they are talking about greater equals to -1. So which one will give me the answer greater or equals to -1? Definitely is this one, right? Because -1 plus something, only you'll get something more than -1. If you have -1 minus something, it is always less than, correct or not? So my final inverse function for this question will be -1 plus square root x plus 2. Okay, so this is my inverse function now. And next, they want us to sketch the diagram, the graph of the inverse function and also the original function. Okay, so again, before I start sketching it, I will want to do a simple sketching first. Right, so I know that my g is having -1 and 2. So this is -1, this is 2. And it will be a U shape. And of course, I'm interested to know what is the x or y intercept. So if you want, you can try to find a y-intercept. So y-intercept means that you let x equals to 0. So 0 plus 1, 0 plus 1 square is a 1. 1 minus 2, you get -1. So that means if you want to sketch this diagram, right, it will pass through -1. So I think my graph should be something like this. Okay, wait. So it will be good if I try to label it clearly like -1, -2, -1, -2, and so on, right? This is 1, this is 2, then this is 1 and 2. Okay, so now I know that my minimum point is at -1 and -2. It will pass through -1. Okay, it should be a U shape. So if you are interested, you can try to find out the x-intercept as well. So maybe here for me, I'm lazy to find the x-intercept. I'll just simply draw it like that. But I know that my y-intercept should be a 1. So my graph might look something like this. Okay, and then for this question, because they want us to focus on only the domain x greater equals to -1. So for x greater equals to -1, it means that we only want to consider this part of the graph, right? Okay, so I have to erase this part. Okay, so the red color part now is actually my original function fx. Okay, then next one, if I want to sketch the inverse function graph, so first of all, I take this coordinate. This coordinate is -1 and -2. To sketch the inverse function graph, I swap the coordinate. It will become -2 and -1. So -2 and -1 will be somewhere here. Okay, by right lah. And after that, I want to take this point. Okay, also, I'm having 0 and -1. So if I want to draw the inverse function, I swap the coordinate for x and y. Therefore, I'm having -1 and 0. So where's -1 and 0? This one. Okay? Then after that, if you still don't know how to connect these 2 points together, right, to make a inverse function curve, then you can try to plot the point 1 and 1, connect it with 0, 0, so that you're having the coordinate for y equals to x. You are drawing the line y equals to x. So this is basically the line y equals to x. And you need to take note that the intersection point for the function f, sorry, it should be function g, not function f. This question is function g. So if you want to know the function g, okay, also the function g inverse, okay, the 3 points between y equals to x, gx, and g inverse should be having the same intersection point. So you can see that this is the same intersection point when you sketch it. Therefore, for your g inverse, you try to join them together also that pass through the intersection point. So by right, it should be looking something like this. Okay, so this is my g inverse x. Alright, so if you double check your diagram again, basically you can see that although my graph is not nicely done, right, but you generally can see that the g and g inverse, right, they are reflecting each other at the line y equals to x. That means the line y equals to x will be the mirror of these two graphs. Okay, so basically this is how we sketch a diagram for the g and g inverse. All right. Okay, then after that, to complete this part, they want us to state the domain and range for the G inverse. Okay, so again, to get the domain for the G inverse, I know that it is equals to the range of G, right? So what is the range of G for this question? So the range of G, you look at the red color part, okay, the red color graph, the lowest point for this graph is -2. Therefore, you're having y greater equals to -2 for the range of G. Okay, which means that my domain of G inverse will be equals to the range of G lah. Just that I need to change the y become the x because domain talking about value x, right? So it will be x greater equals to -2. Okay, then how about if we want to find out the range of G inverse? So the range of G inverse is equals to the domain of G. So for this domain of G, it is already provided in the question earlier, where the x is greater equals to -1. You can see that? Okay, x greater equals to -1. Therefore, when I want to write out the range of G, I need to write out this value as well, just that I want to change the x become the y. Because range, we are talking about the y. So y will be greater equals to -1. Okay, so basically this is how we actually try to sketch the diagram that involve the G and G inverse, or maybe the function and the inverse function on the same diagram. All right. Okay, so this video ended the chapter 2, right? So that means we have covered everything in chapter 2, which is related to functions, right? So thank you very much for watching the video.